where does the tubiness, that characteristic you want from the tube, make the most difference, in the pre or in the power?
That's a great question. And I just want to put one caveat up front, at least in terms of the work that we do here. We're not trying to get tube sound. We're trying to get the sound of music. There are a number of products, especially in the home recording world, which deliberately try to get a euphony out of tubes to kind of warm things up or get a particular effect. A lot of guitar amp tube use is trying to work them in their saturation area to get certain distortion effects, which is not where the hi-fi world runs. I'm going to dismiss the notion of amplifiers that are trying to sound liquid or trying to sound euphonic or trying to sound caramely, because we just don't do that kind of engineering here, at least not intentionally. The reality is the most difficult thing to make with a transistor and make well is a very small signal device, a preamplifier or a phono stage. So if you were looking at doing a hybrid system in terms of the component character, it would make to me more sense to use a transistor power amp and a vacuum tube preamplifier. That will give you the best overall combination. Going transistor pre and tube amp is more likely to give you the worst of both worlds. Going tube pre and transistor power amp is more likely to give you good things from both worlds. I still think it's better going all tube, but not everybody wants to do that. And if you have, say, a speaker that really requires an arc welding amplifier to make it perform right, and there are a few of them still out there, then you want that big D'Agostino or the big Legacy Krell or something.
Today's episode of the Occasional Podcast is sponsored by DeVore Fidelity. DeVore Fidelity has been hand-building their speakers in Brooklyn, New York for 25 years. Each pair of speakers is handcrafted to bring you closer to the music in your collection. Check out their entire line of speakers and where to hear them for yourself at DeVoreFidelity.com. That's DeVoreFidelity.com. Today's episode is sponsored by Nordost. Ready to take your system to the next level? Transform the way you listen with Nordost's world-class hi-fi cables and audio enhancers. Nordost's superior design philosophy and exacting craftsmanship bring out every musical detail, connecting you with the tunes you love. Hear the difference as your equipment comes to life, turning every listening session into an unforgettable audio journey. Nordost, the clear choice for the best connection. That's www.nordost.com. Hey everybody, thank you so much for joining us. A very special guest on the show today, Kevin Hayes of VAC. Kevin has been in the business for a long time, and I think one of the things I find most interesting about audio brands in the space is that longevity is key. And Kevin has been in the biz for 35 years, which is many lifetimes. It's a full lifetime, but it's a many lifetimes, like cat years in the hi-fi industry. So I think we all can just sit back and appreciate that. But we wanted to have him on because he makes a lot of high-end audio gear in the tube realm. And we had a conversation at an audio show a few weeks back here about the KT88 tube, which is utilized in a lot of his amplifiers. I would say most, if not all, of your amplifiers these days. Yes? Yes. It's a gorgeous looking tube. And I just wanted to kind of start the show with a little intro from your perspective about the KT88 tube. Is there a particular reason why you choose it? And what was like your introduction to the KT88 tube, and how do you think it became so special with the hi-fi crowd?
Well, of course, opinions vary about tube types and tube versus transistor and the rest of it, so one can't get too dogmatic about this. But the first point that I would make is it's not just a question of is the KT88 a better tube or is the E300B a better tube? These are ingredients that go into a much larger context. It's like you're making a pot of chili, and someone asks, what's the best ground beef? No, it's what's the best ground beef in the recipe. For an example, if you go back in our history at VAC to circa 2000, the best amplifier we made was based on push-pull 300B triodes. In our continuing R&D, we came up with an input and driver circuit, which performed better sonically, but it wasn't appropriate for 300B. 300Bs, and in fact all the triodes, are relatively insensitive tubes. So they require typically something up to, or in the case of transmitting triodes, in excess of 100 volts of audio swing onto them to secure full output from them. Whereas a tube like the KT88 needs something nearer to 50 or 70 volts to reach full output. So we have a superior circuit that works with KT88s, but not with 300Bs. And it was the overall recipe of that new input circuit and the output beam power tube that surpassed the sound of the older input and driver circuit and the 300B. So again, it's the recipe, not just the ingredient.
Do you think that the individual tubes do have individual flavors to them? Like you're saying, it's an ingredient, but all tubes are certainly not the same. Do you think that the ingredient you're adding has a different tonality or flavor or something special about it, and that's why they're part of the ingredient list?
Every ingredient we work with, whether it's an internal piece of hookup wire or a resistor or a turret lug for a hand wiring anchor point, the tube sockets themselves, the tubes themselves, they all have a sonic signature, a sonic thumbprint. And so they're all part of that seasoning to taste. So in our development process, the first thing is to get the circuit to work correctly. After that, it's then making it sound the way you want it to sound, a process that we refer to as voicing. All these things you can do to the amplifier which change its sound, generally speaking, don't change the way it measures at all. You're looking at secondary characteristics which the linear test gear is not good at catching. And that harkens back to a beautiful quotation that was made, must be 60 or 70 years now, by a legendary engineer named Daniel van Recklinghausen, who escaped Nazi Germany in a concentration camp, came to be an engineer with the H.H. Scott, held 30 or 40 patents, really a rock star in the engineering world. And he made this wonderful statement: if it measures good and sounds bad, it is bad. If it measures bad and sounds good, you measured the wrong thing. So the ear and the brain are nonlinear pattern recognizers, and our distortion analyzers and other test gear are linear devices. So there are certain things that's very easy for us to measure, but is hard for us to hear. Other things which are hard for us to measure, but easy for us to hear. And that leads to a controversy in the mind of some people who think they're following the scientific method. But the reality is audio engineering, because of that subjective character that can't be captured by the instruments, is both a science and an art. I make the comment about those people who think they're following the scientific method because a lot of people on the objectivist side of audio these days seem to forget the scientific method is observe, make a theory, test the theory, observe the real world, go refine your theory. Instead, we've reached a point where people say, this measures good, therefore I know it has to sound good. No, you don't know that. Or in cases where they can't measure a difference, but they can hear a difference, cognitive dissonance prevents them from actually being able to admit they hear that difference.
What do you feel are some of the characteristics that are easy for us to hear, but hard for us to measure, do you think? What are some sonic qualities when you're designing an amp that you find easy to hear, but very hard to measure in some quantitative way?
And sometimes it depends actually on the broader system context as well. Let's say we're developing a power amplifier. We like to use a variety of different loudspeakers during the development process. Electrostatics, dynamics, big speakers, small speakers. And the reason is they all give us a different view into what the amplifier is doing. And they become like multiple points in triangulation of navigation before we had GPS. So, for example, there was one amplifier we were developing about 20 years ago, and it sounded great on the King sounds, it sounded great on the quads, and on it goes. We had one speaker, it was an Italian-made horn speaker, and on this particular speaker, the amplifier sounded, I would describe it as hissy bright, something just hot and grainy in the top end. In the end, we changed just one resistor type, one single part in the amplifier. That speaker came right into line. On the other 10 speakers you couldn't hear, we'd made a change. So the kind of thing you could be hearing could be any number of things depending upon the speaker context as you navigate toward what you hope is a point of higher fidelity. But the kind of things you can change, back up and tell you a story and then drill down a little bit from that point. back in the mid-1990s when we were first making the Renaissance triode power amplifiers. One day they bring a Renaissance 7070 in for me to audition, and it sounds bad. So put it aside, bring the next one in. It also sounds bad. Bring a third one in. It sounds bad the same way. So we halt production, and we begin trying to dig to find out why all of a sudden the dish doesn't taste good anymore. It took us actually about 8 weeks to determine what it was, and it was a change in the factory of origin of the internal hookup wire that we used. And once we determined that, we had to pay to certify all of our internal wire to a known factory of origin, and then had to revoice the amplifier around the available brands. And if you look in one of those amplifiers circa 1995, 96, you'll see there are stripes on yellow background wires and stripes on white background wires. There are 3 factories of origin of the exact same spec of wire. So in the voicing process, as you change part types, you can make an amplifier seem to be more or less powerful. You can make the bass seem to have more or less control. And that's, again, without affecting the actual measured damping factor of the amplifier. You can make it seem to have more presence or less presence, more air or less air. Basically, any character of music or high-fidelity buzzword you can think of can be affected by changing the wires, resistors, capacitors, circuit layouts in the amplifier. In our case, my process is always trying to bring back that feel of music, that sense of presence, projection, solidness, just an organic plantedness and presence. When you play an old Cole or Sinatra record, the singer should step forward to the band, and the band should go back 30 feet behind and see vividness, dynamics, micro and macro both. All those clues that say, I can close my eyes and suspend disbelief and think this is real for a while.
Now, you've obviously made a choice to go with the tube as your primary form of amplification. Do you find that the tube itself, those tube designs, contain something special in the sound, or can the same effect be achieved with solid state in your mind?
Well, we do R&D both with tube and solid state on an ongoing basis, and my mind is not closed to the other technologies. But at the time the idea for VAC was being formed in my mind, it was based on tubes because everything I'd experienced up to that point in my life told me the tubes preserved more of the musical magic I was looking for. And I had been through a number of very high-end tube and transistor amplifiers by that time, and I began digging into the measurement aspect of them sometime in my mid-teens. And there's a legendary brand that I did a lot of testing on that I won't name. It wouldn't be nice. A 200-watt amplifier claimed, but in fact, if you were running a 10 kilohertz square wave into it, it was more like a 15-watt amplifier. And its channel separation at the high end was only about 20 dB. And it was amusing. Years later, I saw Gordon Holt do a review of one of this amplifier company's pieces that was derived from the one I'd had in my teenage years. And he mentioned the soundstage seeming a bit narrow, but, and I paraphrase, I didn't bother to measure because I know it would have measured perfectly. No, actually, it wouldn't have. Tubes were where my interest was, and we moved forward in that direction because of it. In more recent years of research and study, the fundamental fact is the vacuum tube is the most linear amplifying device ever invented. Triode tube is far superior to anything else ever invented. It follows what's referred to as a two-thirds law, Langham-Childs law. And transistors are much less linear, especially the bipolars. So it becomes a bit like an analogy if you were a tailor. What fabric would you want to use? Would you want to use silk or would you like to use burlap? The tube is just better material. You can make a more linear circuit with fewer engineering tricks. And every bit of complexity you put into a circuit to make it measure right has the potential to damage the sound in meaningful ways. There's no perfect resistor, right, no perfect wire, no perfect capacitor. They all deviate from the ideal in various ways. So the more of them you use, the more chance you have to foul up the sound. And so the tube's linearity leads to circuit simplicity and tends to lead, therefore, to a better result. And the fun part, as well as the challenging part of engineering with tubes at high enough level is everything you do matters. and you're looking at implementations, wire routings, grounding layouts. You're hitting all those points where the textbook statements about, well, you should always star ground this. In point of fact, you shouldn't. It's a lovely theory to start from and deviate from, but everything matters, and that's one of the reasons why everything we make I listen to personally before it gets to leave, before it's approved to leave. Because again, hearkening back to the earlier discussion, there are things you can hear that you can't readily measure. So a perfect test card isn't a good enough qualification to ship a piece to a customer here.
We talked a little bit about the 300B and the KT88. I think that the 300B has a reputation for having liquid mids quite often when it's implemented correctly. Do you find that the 300B, from your experience, and the KT88, do they measure differently? And is one superior in terms of measurements?
It depends on which measurement you look at. There are a number of meaningful measurements for a vacuum tube, and on some of the parameters, the 300B is better. On others, it's KT88 that's better. Almost all engineering at some level is a compromise. So what we're trying to do as designers is to push the frontier of compromise as far away from us as we can, and then make that compromise as artfully as we can in a way that serves the veracity of the music as best we can. To me, music is a form of communication for emotion, and it has to move you first. It has to touch you, whether it's the way a singer is phrasing or just kind of the hollow sound of a drum in a big room, which can kind of a lonely and poignant sound all by itself without words. The sound character of tube types. It's one that I think has a lot of misunderstanding among people who haven't worked with them a great deal. So, for example, I'll get a call from someone one day who says, EL34s sound warmer, don't they? Well, that person has probably heard an EL34 in this brand amp and some other tube in this other brand of amplifier. So it's apples to oranges in context. And then he's failed to take into account that 30 different factories have made EL34, and every factory's EL34 has its own sonic characteristic. So when someone says, EL34s are always warmer than KT88s, it just shows a lack of experience. I understand how it happens. We've all been through that phase in our lives and trying to understand the complexity of the real world. In point of fact, it's a much more complicated topology terrain than that. So the very first amplifier we did back in 1990 was intended to be based around the KT77, which is a British derivative of the EL34-6CS7. But the 77 supply dried up right about the time we were launching, so it became an EL34 amplifier. And before we launched the company, I spent about 2 or 3 months listening to close to 200 permutations of 12AX7 input tube, 12AU7 driver tube, and EL34s. And of all of that, I only found about 2 or 3% of the combinations I thought were really good, which again underscores the everything matters legacy of the engineering. By the way, that same difference between this brand of tube and that brand of tube, it still pertains to transistor engineering. I remember we were doing a design on our DA converter back in the early 90s. DACs read the data into a memory chip and then pull it back out according to the clock at their own pace. I was looking at different brands of the same memory chip, National Semiconductor and TI and so forth, and every memory chip sounded different. You don't know that with transistors. All that is still going on there as well. The other interesting thing about that, kind of a digression here, is a lot of semiconductors, transistors, have a production life in terms of months or just a year or two. It's not uncommon for a transistor stock to be released and discontinued in 6 months to a year and a half. You'll find certain designers, Nelson Pass comes to mind, who go out and try to find all of the available of this particular part because that was the magic part for that particular design. And so some of these companies that have been around doing solid-state electronics for 50 years, they'll rebuild your amp when it fails, but they're actually on their 4th version of output circuit topology because they can't get the parts anymore. As the user, you would never know that. But it's a real headache. I remember talking on the bus at CES one year with Steve McCormick, who's a very talented engineer in the solid-state world, and he was just bemoaning how by the time you've gotten the device and figured out how to make the best sound out of it, you can't get the device again then. On the other hand, you look at this tube, the 300B, it's been in continuous production since 1934 or 1935. I like that.
I think that's a very interesting point you make, that part of maybe what we think we love the 300B for is really just its availability. Its ability to stick around and stay in the production. Maybe it's a cyclical thing all by itself, that we love it, therefore more people make it, and therefore it gets used again. And if you don't have that constant cycle going hard and fast enough, and it breaks, right? And then we have no more of a single individual tube left.
Well, the fact that the technology is less fugitive is very attractive. And one of the design goals I have these days is to select tubes such that in 50 years, ideally, you'll still be able to retube that amplifier. Because as far as I'm concerned, our electronics will still be working a century from now. And one of my fondest hopes is, long after I've left this plane, someone's going to pick up one of our electronics and say, I don't know who these guys were, but they must have believed in quality. But one of the points about 300Bs, I'm not sure if it'll pick up here or not. It's a somewhat more linear tube in terms of transfer function than a KT88. That's favorable. But there are certain aspects to its construction which are problematic. One that you have probably seen looking into them yourself, but you can't really see on camera well, is the innermost element, the filament, is a wire stretched back and forth between springs at the top, which, if you think about, should remind you a lot about a guitar string or a piano string. Mm-hmm. And that topic comes up not by accident, because one of its problems is it's like a little spring reverb. It rings after the sound. And it's not uncommon. It depends. It varies from individual tube to individual tube. It's tuned and how much vibration there is. You can be playing a song, hit pause on your CD player, and the moment you hit pause, you hear the speaker go, woo, 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 because you're hearing that structure in motion. Okay, that's a real problem, especially if you're pulling more power out of them or using very efficient loudspeakers. So that's a problem. Secondly, they're insensitive, so you need a larger gain circuit to drive them. That's now pushing part of the linearity onus from the output tube back to the input circuitry more. They have a lot more stray capacitance, so they're harder to get a very wide high-frequency bandwidth out of. So again, it's compromise. It's pros and cons. The general class of tubes we're using now, the KT88 and the earlier EL34, are part of a class of tube referred to as power pentodes, or more properly in this case, beam power tubes. And the beam power tube legacy goes back to the 6L6, which I want to say was commercialized maybe around 1937. It was actually invented in Great Britain, but transferred to RCA, and they're the first ones to commercialize it. And the British equivalent tube that followed was called the KT66. That tube was a milestone in terms of efficiency, but it had pretty high amount of distortion, and it's not a particularly winsome tube overall. The British then did a variation of the EL34 called the KT77, and that's a pretty sweet tube. At least the original British versions were. And then about 1953 or so, Tungsol developed a tube they called the 6550, and the British, in their kind of one-upping way, brought out the KT88, which is a very similar tube, but with slightly stronger characteristics and better control in the knee area of the transfer function. That's going to get too deep into the weeds for most listeners, but the KT stands for kinkless tetrode, and it is not uncommon for tetrads to have an area of ambiguity very low in the voltage, where you can get this current output from that input signal or that input signal, and that's not a good point for fidelity. And the KT tubes overcame that particular problem, which is a better job with lower distortion. The KT88 is in many ways the premier tube of that entire engineering legacy, although there have been a series of super variants that have come out: the KT90, the KT99, the KT120, the KT150, the KT170, and who knows where that will stop. I think sonically and in terms of purity of performance, the KT88 is the superior of all of those. And it's not all that hard to see why. All these more powerful, if you will, versions have large structures. Now, one of the stray parameters of a vacuum tube that makes it imperfect is something called stray capacitance. Inadvertent coupling between the cathode, the grid, and the anode, and the heater, and all the internal elements. Thinking back to your early physics classes, you take two conductors and separate them, and you've got a capacitance. Some charge will try to form between them. It's not particularly bad with the vacuum tube because the dielectric for the stray capacitance is a vacuum, which is the best behaved dielectric known and also the least efficient dielectric known. So you get very small amounts of capacitance and very well behaved compared to a transistor where you get much order of magnitude more stray capacitance and much more poorly behaved capacitance. So as you make these structures in the vacuum tube bigger and bigger, you get more stray capacitance. You get more outgassing of impurities from the internal metal structures. And you can see this on the data sheets for, say, a KT150. The stray capacitance parameters are much higher, which leads to theoretically possibly some limitation on high-frequency bandwidth compared to a KT88. You see them say the biggest resistor you can use on the grid-to-ground return in a fixed bias amp is only 50K, whereas a real KT88 lets you use 100K. That tells you they're concerned about gas currents in the tube, relates to impurity from the production process, probably from the larger structures. And then larger structures are going to have a different mechanical resonance characteristics. There are all these things at play. At the end of the day, people can be forgiven for thinking, but the KT170 will give me more power. And the answer is sort of analogous to you can look at your car and go from a V-rated to a Z-rated tire, something from 120 mile per hour maximum speed to 180 maximum speed. Okay, did your car go any faster? No, it didn't. It's the potential. So if you simply take a KT88 amplifier and you plug in a KT170, you're not getting any more power. I mean, individual pairs of tubes might vary a little bit in the power they give you, just from production variance, but you're not going to increase your power by 50% by putting in the giant, mighty KT170. To get more power out of it, you have to increase the plate voltage substantially, which now gives you an amplifier which is no longer backwards compatible with the KT88, which bothers me because, again, in the years I want to be able to retube that amplifier. There's a lot of KT88 history out there. There's not that much KT170 history out there. So anyway, bottom line is sonically as well as in some of the engineering parameters, I think the basic KT88 is a better tube. Your mileage may vary. If you like the other tube better in your system, use it. Our amplifiers can use all of them. I just recommend the 88.
Our friends at ZMF Headphones are sponsors of today's episode. ZMF is a curated collection of various sounds and styles in the form of dynamic and planar magnetic wood headphones, designed by founder Zach Merbach since 2011. ZMF has garnered an A+ recommended component in Stereophile, Headphone of the Year on Headphonics.com, and been a 2-time winner of the SBAF Golden Schlong Award. ZMF Headphones. That's the letter ZMF. Headphones.com. ZMF Headphones is the place to go to check out ZMF's collection and learn more. ZMF, traditional craft and modern acoustics. Tired of audio reviews that sound like they were written by robots? Us too. For the last 15 years, Part-Time Audiophile has been an open revolt against boring. And this year, we're doubling down. We have a brand new look and a brand new name, but the same old attitude. Find us at pt.audio for all your turntable throwdowns and amplifier face-offs. Great sound meets good times at pt.audio. Class A amplifiers tend to throw off a lot of heat. It's part of their process and how they work. Mm-hmm. It's very, someone who has any experience with a tube amplifier may also observe that tubes get very hot. Is this a part of the process as well? Why do they get hot? And is it for the same reason that a Class A amplifier gets hot?
First, The vacuum tube has one unique thing to it. To make it work, it has to get the cathode of the tube hot enough to emit electrons into the vacuum. In the case of the KT88, let me do the math really quickly. The heater is about 12 watts. So you've got 12 watts of power here in a housekeeping circuit that you wouldn't have to have in a solid-state circuit. Beyond that, if I were to make a pure Class A tube amplifier and a pure Class A transistor amp of the same rated power output, the only difference in their heat output would be that 12 watts of the heater. The class of operation is dominant. The classic definition of a Class A amplifier is always making full power all the time. The power is either going into heat or it's going into sound, but the power is flowing at all times. Similarly, if you back into the Class AB region, and let's say you've biased your output devices to have one of them hit cutoff, say at 30 watts in the case of tube and transistor, they're again going to have the same amount of heat dissipation, except for that small amount that the heater of the tube has. It's there, but it's insignificant compared to the 40 or 50 watts of plate dissipation or heatsink power being drawn off of the transistors and so forth. So, but it does point out that there are a lot of amplifiers now being sold as Class A that don't follow that classic definition of what a Class A amplifier is. The reason you want a Class A amplifier, theoretically, is because you are running your signal right in the middle of the sweetest, most linear part of the output of the device. So if you imagine a chart that has output versus input, you've got kind of an S shape that develops in a device. If you have your center of your signal, your quietest signal, right in the middle of that, it's the most linear transfer point, and then you hit your power limit on both phases at the same point where the curvature, begins to occur. That gives you the lowest distortion, the best fidelity, and the most heat. Beginning maybe 30 or 40 years ago, some very talented solid-state designers began doing a technique which is sometimes called sliding bias or dynamic bias. I think stasis bias is also one of those, but don't hold me to that.
We had talked briefly about, the heat of the amplifier, and that when you go to an audio show, Sunday is usually the best day to hear any rig because it has time to settle in. People have time to correct if they have issues. But one of the ideas is that also the longer a tube amplifier and any amplifier really plays, in essence, it somehow warms up and the sound gets better over time. Is there any scientific evidence from this, from your perspective, and is it true, or does an amplifier sound as good from your experience? This is the second you turn it on till like if it's been running for 8 hours straight.
The answer is the runtime certainly does make a difference, and there are a couple of different time scales in a product's life to think about in this. The first one would be the initial break-in. You take a basket full of brand new components, you wire them together to make an amplifier. In my experience, that amplifier will season in, if you will, sonically for anywhere between 80 and 250 hours before it reaches its mature voice. And again, some of the objectivists would say that can't possibly be. And I can give you a really simple example to make it understandable. Every amplifier at some point has capacitors in it, coupling caps or power supply caps or what have you. The capacitor typically is a wrap of a metal, say a metallized capacitor. You have a plastic film with a metal conductor on it on each side, and you've wound a spiral of this to make a tubular capacitor. Okay, you're probably also familiar with the fact that you can also make a microphone on the capacitor principle, and you can make loudspeakers on the capacitor principle. Microphones we call condenser mics, typically. That's a capacitor, two plates spaced apart. And in the speaker world, we call them electrostatic loudspeakers, two metal panels charged apart from each other. So at some level, your capacitor, because it is not infinitely rigid, it can move. So as you drive signal through it, there's a little bit of motion between the foils and the surrounding plastics. Also because capacitors can pick up signals, whatever it does after the fact, any overhang that's not perfect in mechanical tracking can have a very slight character fed back into the amplifier signal chain. So you've got a device which by definition is both a speaker and a microphone. It's part of your amplifier. As you play signal through that, you are, in a sense, at some very small level, working that plastic. You're working that dielectric. You're forming a mechanical characteristic in there. Mm-hmm. Every pair of wires put side by side are a stray capacitance as well. There are lots of things in an amplifier that can break in, but the capacitor, I think, is one of the easiest ones to visualize and understand. You go through the first 250 hours or so, and your amplifier has this very standard sound now. The question now becomes, and you turn it off and on every day or every week, does it have the same sound? And to my ear, typically, you can turn an amp on cold, and within a few minutes, it sounds very good, and within 15 to 30 minutes, it sounds just like you want it to. There have been other reviewers, Harry Pearson notably, who would say, no, it has to be on for 2 days before it sounds right. I've never experienced that, but I'm not going to say somebody else is wrong. Maybe they hear things I don't. The other phenomenon that we see all the time, and goes back to where you and I first met, Brian, is the trade shows. So you take an amplifier which is fully broken in, and you put it in a box, and you shake it in a truck, and maybe you put it on an air freight so it got down to the temperature of 40,000 feet, which is nice and cold, and all the metals contract when they get cold, and you've shaken it and all that. So when that amplifier, which was fully broken in, gets where it was going, it's not fully broken in anymore. It has a resettling time sonically after transit. So that's one of the reasons why at a trade show we try to get the amps running and the cables cooking and everything as soon as we can after getting there, because people have known for years at the shows everything sounds better at 4 o'clock on Sunday when you have to pull the plug and pack up again. So getting around that is an important thing. It also harkens to the question of should you leave your equipment on or turn it off? And interestingly, the answer is different for a preamp or a power amp in the vacuum tube world. There are 2 basic wear factors relative to vacuum tubes. One is simply the number of hours of operation, kind of like the number of revolutions your tire has had on the road. The other is the fact that when a tube is off, it's at room temperature. When you turn it on to get it to heat up, that little small core in the middle, that heater, rises up to about 1,000 degrees, orange hot. So all the structure of the tube expands when you turn it on and contracts when you turn it off. Materials are liberated inside that vacuum and reabsorbed inside that vacuum as the off-on cycles occur. So in the case of a preamplifier where you have the little tubes, there's not a whole lot of power being run through these tubes. The number of hours of operation really aren't burning up much of the tube life. But the off-on cycles become significant. Back in around about 1957, the engineers at Capitol Records did an experiment. They took a batch of 12AX7 tubes, a very common, useful twin triode tube, and they went through and they measured and recorded the data on all the tubes, and then divided it up into 2 groups. They went into identical equipment. One rack of equipment ran 24/7 for a year. The other rack was turned off and on once per day. And at the end of that year, they pulled the tubes and remeasured them. And what they considered was that for their purpose, as a recording studio, the ones that were turned off and on once per day were at the end of their useful life. The ones that ran 24/7 were actually more nearly matched than when they were near, and were on average quieter than when they were new. So my answer is for preamps, leave them cook. Don't worry about it. And I've been doing that for a number of years in my own home, and people tend to consider that maybe a preamp tube life might be 8 or 10,000 hours. I've routinely seen 20,000 hours on tubes that run that way at my house. If I'm going away for a week, I'll turn the preamp off. But if I'm listening off every day, I'll just leave it run 24/7. On power amplifiers, that KT88 is putting out a lot of effort all the time, and that's a wear factor for it. So for power tubes, power amplifiers, I would say, turn the amp on Friday night, turn it off Sunday night. Otherwise, turn it off and on once you're going to be listening through the days, but don't necessarily turn it off and on 20 times during a day. Turn it on in the morning and turn it off at night. And that's the best way to balance the wear factors to get your longest tube life, which in the case of the KT88 run that way should be about 8,000 hours, 6,000 to 8,000 hours on average in our equipment. Some other companies say only 1,000 or 2,000 hours in theirs, and I wouldn't contradict them for their circuits, but we've had very good lifespans on KT88s.
I said we talked about the pre and we talked about the tube. Now there is some discussion online about Should I have a solid state pre or a tube pre or a solid state power amp or a tube power amp? From your experience, do you feel that the technology can be used in both? Or where does the tubiness, that characteristic you want from the tube, make the most difference, in the pre or in the power?
That's a great question. And I just want to put one caveat up front, at least in terms of the work that we do here. We're not trying to get tube sound. We're trying to get the sound of music. There are a number of products, especially in the home recording world, which deliberately try to get a euphony out of tubes to kind of warm things up or get a particular effect. A lot of guitar amp tube use is trying to work them in their saturation area to get certain distortion effects, which is not where the hi-fi world runs. I'm going to dismiss the notion of amplifiers that are trying to sound liquid or trying to sound euphonic or trying to sound caramely, because we just don't do that kind of engineering here, at least not intentionally. The reality is the most difficult thing to make with a transistor and make well is a very small signal device, a preamplifier or a phono stage. So if you were looking at doing a hybrid system in terms of the component character, it would make to me more sense to use a transistor power amp and a vacuum tube preamplifier. That will give you the best overall combination. Going transistor pre and tube amp is more likely to give you the worst of both worlds. Going tube pre and transistor power amp is more likely to give you good things from both worlds. I still think it's better going all tube, but not everybody wants to do that. And if you have, say, a speaker that really requires an arc welding amplifier to make it perform right, and there are a few of them still out there, then you want that big D'Agostino or the big Legacy Krell or something.
It is also a function of price and cost, because when people are at that stage, sometimes you can obviously find a much less expensive version in some of those areas. When you get into tubes, I think that it becomes one of those things where, while cost is a big problem, because you can't really get a very inexpensive tube design that sounds great most of the time. Now, you can go vintage, you can do this stuff, and there's a lot of things, but I think when it comes to that, what, in your opinion, makes a good tube amplifier so expensive? For the people who are sitting here listening to this podcast thinking for the first time, I'd love to get a tube amplifier, do you have some insight as to why they generally are so expensive to design and make these days?
I'd say the first part, which makes owning a tube power amp a bit more of a commitment, is the output transformer itself. Vacuum tubes are a higher impedance, more voltage-oriented device compared to a lot of solid-state, which tend to be low-impedance, current-oriented devices. And the way loudspeaker practice has evolved, they're primarily low-impedance current devices. So you've got a tube that wants to see, say, 3,000 ohms here, and a speaker that's 4 ohms there. You have to bridge those two points. That's done through a very wonderful device called a transformer. Now, I probably shouldn't call it a wonderful device. Done correctly, they are fabulous pieces of equipment. Done in the average fashion, they can be terrible pieces of equipment. It's amazing. Transformer design to this day remains a little bit of a black art. Our design was worked on 36 years ago by a gentleman who had apprenticed in the days of Harman Kardon Citation and Sid Smith at Marantz and Macintosh, and in fact tell tales from the early 60s about shouting matches between their chief engineer and Sid Smith and phones being slammed down and all these kinds of things. And so when we first approached the design of our transformer with him, I gave him a series of parameters I wanted to achieve. And they were 2 to 5 times more stringent than any of the prior art that I had found. And the fellow told me, you can't do that. I said, well, work on it and see what you can come up with. And I got this lovely phone call about 3 months later. The guy said, I can't believe it. I did it. And he sure did. He designed a transformer which no matter what we do for 35 years, we can't improve on. And he's now gone to his reward, but his engineering expertise is still singing every day in our products. And interesting, there is a point of design in that magnetic on the secondaries where there are, let me get the number right here. I'm going to get the number wrong, so forgive me. But there are 2 layers going to the 4 ohm tap, and they could have equal numbers of turns of wire, say 5 and 5. But the design has, let's say, 7 and 3. And the engineer where the transformers are being wound now looked at it and said, well, I can make those the same count. It'll wind easier. It'll be more uniform. It'll be more consistent. And it'll have no effect on the performance. It took the frequency response of our forum tap from 80K down to 10K. It can't happen. Try it. He wound it both ways. Yeah, it sure does. It totally violates every rule he thinks he understands for transformer design. But the old timers, they had that feel for what to do, and they did it. And so it's very much of a difficult art, is my point. If you don't get the output transformer right, you're not going to get all the magic that you can. And the problem becomes transformers are expensive devices, particularly the way we wind ours. I won't get into all the winding techniques, but there are multifilar techniques in the winding. Most people wind transformers now on plastic bobbins. We wind ours with no bobbin, no dead space in that magnetic circuit. Most places can't wind that kind of transformer anymore. And by the time you've made the transformer that I want, and the power transformer that I want, and you put the grade of resistors in that I want, and made a decent looking chassis, it's going to sell for $10,000 from a dealer. I can't get below that point with an amplifier that I want to see our name on. There are other companies which are, I think, far more effective at making those compromises on a budget. Rogue Audio comes to mind. They do some excellent work in their price range. I can't reach that in something that I like the sound of and want to produce. So, the entry point to us is about 10K, which is pretty high in one sense, but we try to make it a very high value in terms of sound character that it delivers. And when people say, we can't afford that, my answer is there's a tremendous amount of used VAC gear that's been made over the last 35 years. You can find a piece there for half or a quarter maybe on a good day of what the original price was and be far ahead of the game, and I will help you find what piece that is. I won't sell it to you, but I'll help you find the one that'll fit your system best. But if you want to buy a new tube below 10K, the choices are relatively limited. As you begin going above that, I get to go from a volume control, say, that cost me $50 to one that cost me over $1,000. I'm talking my cost, not the retail effect. I get to go to plating techniques that cost a great deal of money but give me better shielding. I get to go to not a 50-cent resistor. Let me back up. The little blue resistors you see in most people's electronics, they're about 2, 3, 4 cents a piece. The larger brown RN65 metal films, they're 50 cents to $2 depending these days. Z-foils you see in our statement and master gear, those puppies are up to $35 a piece. And there are a lot of them in some of those circuits. That's where the price builds up. Or in the case of our statement preamplifiers, we take a 1-inch thick slab of brass and machine it out to clear circuit areas to make a very heavy mass decoupling stage. Brass is expensive, kids. That slab of brass is $600 or $1,000 might cost before it's machined. That's where all the money is going that you don't necessarily see when you first look into it. But all of it has an effect. The question is, what do you need to enjoy the music? And if a Bose Wave radio lets you enjoy the music, then use the Bose Wave radio. If you are just hungry to get that much closer to the performer and what happened in the studio, then you wind up going all the way. The sad thing, I wish I could tell you there's not much difference in sound between an $80,000 preamp and a $30,000 preamp, but I don't really understand it always all the way myself, but there is. In fact, I'm actually wondering at this point, we first began doing the absolute cost no object things about, must be about 15 years ago now. And my supposition was that when I doubled the cost to produce something, I would get a small improvement in sound. And at this point, we've gone up to integrateds as much as $160,000 now. I have yet to find that point where the sonic improvement begins to really flatten out and become diminishing marginal returns. There's more to be had than we realized for a long time. Now, of course, with the cost no object products, the goal then becomes to find out why that performance happened that way, and then find ways to put that, or a large part of that, back in the more affordable products. Much like a car company might do Formula One racing, and then try to adapt some new suspension technique into their, $40,000 sports sedan that you can buy and drive on the road.
One of the techniques that amplifier designers often employ is the idea of negative feedback. Do you use negative feedback? What's your little explanation for why it's used, and how do you view it in terms of your designs?
I tend at the end of the day to think of negative feedback as being a very potent spice. Analogy again to cooking. You use only as much as you need to, only when you need to. Our preamplifiers, signature, master, statement, are zero feedback devices. And yet they deliver high current into loads as low as 100 ohms. That's done through a lot of very careful engineering and very careful transformer design. Our power amplifiers back in the era of the 300B, they had adjustable feedback levels, but typically they'd be run as zero. The KT88, I think, needs just a little bit of feedback around it, but not too much. And part of that determination relates again to hearing the way it sounds on different types of loudspeakers, finding out where that sweet spot seems to be and hewing to that. But it's not very much. If you're designing trying to get the very best linear measurements, you'll try to get a lot of negative feedback in something. And in fact, there's one designer now who works primarily in the solid state world who's trying to push the idea that you really need 90 or 100 dB of negative feedback in an amplifier to make it really work right. Respectfully, I think the analysis is flawed, but again, the proof is in the listening. The feedback question relates to a secondary question on the KT88, which is you can run the tube as a tetrode, you can run it in what's called a triode connection, or you can run it in an ultralinear connection. Now, again, other designers have different circuits. I'm not going to say that what I've observed is going to be true for every product and every designer, but I don't like the sound of the KT88 triode connected. To me, it just gets kind of bland no matter what you do with it. And I remember when we first brought our KT88-based amplifiers out after years of doing the 300B, I was concerned there'd be a psychological backlash about it not being triode. So I put a switch on there to allow people to switch the operation to a triode connection. One of our first adopters went from the old Renaissance 140s to our new amp. And he called after a few days to say, how great this was and how great that aspect was and how this wonderful part of the sound was. And he slowed down and said, but tell me, what idiot put the triode switch on there? So we don't put triode switches on anymore, but that was just part of the bridge in people's thinking between the two types of amplifiers. Tetrode modes, or you might call them the pentode mode, even though it's technically not correct, it's the way most people recognize it, tend to have kind of a caramely, squealy kind of sound and higher amounts of distortion. So the mode that we operate in is an ultralinear mode. Just like saying every EL34 sounds different, every ultralinear implementation can sound different. It depends upon the way the windings in the transformer have been configured, what ratio has been chosen for the tap point for the screen. A whole range of things go on, and I'm pretty confident in saying that where we operate the tube is fairly unique. It gets more of the triode virtue that you can do in the ultralinear technique, while still preserving a pretty good power output. There was an old song back in the swing era that said, "It ain't what you do, it's the way that you do it. That's what gets results." This is part of that category. A lot of experimentation in terms of where this tube really wants to sing. And we think we found it, but we always keep experimenting. I never want to believe my own theories. We routinely challenge our own theories because you have to let the world tell you about your theory, not let your theory tell you about the world.
I think when we as audiophiles look back collectively, we feel that the tube and obviously the record player, the analog system, were pretty remarkable designs at the time. When you look back at history from, again, your perspective, this is just your opinion, do you feel like really impressive design has been linear over time, or did we create great things and then get a little bit lazy, or are great things still being created at the same clip is the question, at the same clip, right? Because we have AI now. And when I was a kid, the example I always give about music is that you had to be a pretty good musician to make music. Now you just need ideas and the computer does a lot of the work for you. Has any of that been laid over amplifier design over time? Or just design in general from what you kind of think about the beauty of good engineering and design?
Well, I think the question of AI has to be held in abeyance until we see what actually happens. Some people have published online, they'll ask AI to design them, a tube amplifier or something. And, what comes out is kind of interesting, but it's missing fundamental connections required to make it work and so on. So how that eventually goes, I don't know. And secondly, of course, the computer lacks the ability to hear what our nonlinear ears hear. So I don't think the human factor is ever going to be removed from a product which is explicitly there for human enjoyment, which is all that music is and all that hi-fi reproduction is. I think it's fair and properly humble to note that the people that were really giants at this are the ones who came before us, the people that first figured out how to make a tube amplifier, the people that first figured out how to make a tetrode behave in a more linear fashion, the people who first developed negative feedback at Bell Labs, pro or con, the guys that first went to an amplifier which really measured pretty well, like the DTN Williamson amplifier, then the ones which followed that they made the amplifier have 5 times more power and 1/5 the distortion. I'm thinking there of the Frank McIntoshes, the Sid Smiths for Marantz, the Stu Hageman and Harman Kardon, Daniel von Recklinghausen and H.H. Scott. These guys were doing the trailblazing. Some of them were damn smart engineers, and I don't feel that we're working in quite the same category now. We're more in an era of refining things than fundamental discovery. Now, that does not mean we don't stumble across some fundamental discoveries, but I think that we honestly owe a giant nod to the people that came before us, because we're standing on their shoulders in a very real way. And even among the more modern companies, you look at a company like Audio Research, for example. While I like the sound of our amplifiers better, I always think back to, William Zane Johnson is the guy that kept saying vacuum tube all through the late 60s and early 70s when people just kept going transistor. He kept the flame burning. God bless him. We're standing on his shoulders too. We never want to begin thinking that we are uniquely clever people just because we're privileged to have this giant legacy to draw from. Back when I was in grad school, doing my master's and doctorate degrees years ago, I was up at Duke University, and their library had open stacks on engineering and physics going back to about 1910. So I'd spend the weekends in there mining Westinghouse Review and RCA technical notes and old Journal of the Audio Engineering Society articles and so forth, and making giant stacks of photocopies of papers. And I would honestly suggest that we have actually forgotten the majority of what we ever knew about a lot of these kinds of engineering today. The legacy back there is huge, and it would take lifetimes to mine it at this point. Again, hubris is not warranted in engineering. The other thing that I think is worth noting is that there was a book written a number of years ago by a guy named Richard Foster, who was a partner at McKinsey & Company, the consulting firm. And the book was called Innovation, the Attacker's Advantage. And he looked at the history of technology, innovation, and how it rolls out. And he developed a model that you might call an S-curve model. So if you imagine a graph which shows performance on the vertical axis against R&D money, R&D time, R&D effort on the horizontal axis, technologies, it's hard to make them work at all. Oh, that's how that works. Oh, I can do that. Oh, lots of improvement. And then at the top end, it's hard to make it any better. That's the mature phase where it becomes hard to make better. So you think about, if you're old enough, calculators. When I first went to undergraduate school, a calculator had 4 functions and Nixie tubes that sat on top of a counter with a power supply below it. By the time I went to my next level of college, it was a $150 scientific calculator. And by the time I had my first job, it was a $20 credit card size calculator. That's the S-curve. Slow development, lots of improvement, and not much really has changed since then. So, in that analysis model, both transistor and vacuum tube audio engineering are very, very mature arts. We're not in this part anymore, we're in that part. And that begins to explain a phenomenon that you see where, let's say, some reviewer has a tube amp. And after 5 or 6 years, he hears a transistor amp and says, oh, maybe transistors have caught up. And then he hears a new tube amp and says, oh, never mind, tubes are still better. You're looking at the two technologies kind of parallel with a gap between them going up a bit over time. And so if you check the transistor amp here and the tube amp there, the performance might look more similar than if you take contemporaneous designs and compare them. A lot of what's going on now in terms of improvement in sound pertains to both technologies, metallurgy and jacks and capacitors, insights on grounding technique, on shielding techniques, resonance control, mechanical damping control. And there are still circuit design things happening, not to rule that out. But again, to a large degree, we are refining as opposed to breaking ground on a lot of these circuits. The other intriguing thing is you look at the history of engineering through the 1950s, for example, this big turn from low power, zero feedback triode to much higher power, very high feedback pentode. You had designers, I think, then who were very well able to measure what was happening, but maybe a bit handicapped in terms of hearing the effects of what those new techniques were developing. Because it's 1952, your input device could be a ceramic cartridge and a 78 RPM record. Your speaker could be a JBL horn system. Not to knock it, people love them, a lot of vintage things, but in terms of resonance performance and fidelity and extension, they're highly colored devices. I'm not sure the guys that pushed to go 30 and 40 dB of feedback on their power amplifier were really able to hear what it was doing to the sound. These days, we have much better sources, on average, and certainly better transducers, loudspeakers, better phono transducers, phono pickups than they had back then. So we're able to look back and say, that improvement that you made there may not have been an improvement. Let's back up and try a different direction and try a different combination of circuit techniques and ideas. A lot of it also comes down to the question you have in your mind as a designer. What are you trying to solve? If your design goal is, I want to make 100 watts at 0.01% distortion, I think you're asking the wrong questions. You need to be asking, what stages of circuits do I need? How do they relate to each other? What do you want to pass between those stages? What do you not want to have pass between those stages? And that leads us down roads in terms of power supply designs and points of virtual netting of the currents, creating a virtual grounds, if you will, at points in the circuit, and layout issues and so forth. So there's still a lot to be done, but the really fundamental hard stuff is old.
When we talked about the idea of legacy, you said you really hope that your amplifiers are around long after you are, aside from just having products that remain in the market. What do you feel is the legacy that you want to leave behind, either for audio or the world or whatever? What is the main thing that you want to leave?
I want to leave people enjoying music behind. I want to leave a value behind. The nice thing now is I said we've been doing this for 35 years. The company launched in 1990. So I now occasionally see a 35-year-old VAC come back for a checkout. Someone's bought it used and they want to make sure it's working right and so forth. And yeah, they're still in good shape and they're still running well. And the fact that you can buy 60 or 70-year-old amplifiers off eBay and some of them still work all testifies to where this might go. I want those people who knew me and interacted with me to think that they were treated with respect and treated fairly. I really want to do something that is enduring and of quality and that pleases people and try to treat them right. I want to be able to, when I look back, and as a side note, I plan to live to be 120 and to be working at VAC the last day I draw breath. When that day comes for that last breath to be drawn, I want to look back and say that it was an effort well spent.
So no retirement for you, huh? You're not looking forward to retirement?
Why would I want to retire from something I love? Are you kidding? Even before I had an amplifier working, I had dreams of maybe eventually having some contribution to this industry, to this passion, to this hobby. And I got to tell you, it is one of the greatest blessings and privilege in the world to be productive in something you truly love. And I am often surprised and humbled by the fact that I've had that privilege.
Yeah. Kevin, thank you so much for coming on. It's been very enlightening. Great time. The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes parttimeaudiophile.com, The Occasional Magazine, the PTA newsletter, and audiohead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. The Occasional Podcast and its original associated music is monitored, mixed, and mastered on the Focal Trio 6 BE studio monitors. AI songs produced by Udio.com. If you haven't already, please subscribe to The Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.